Deep beneath our feet, buried in rock layers over 65 million years old, scientists have discovered something that should not exist. Microscopic spheres of rare metals are scattered across these ancient sediments in a pattern eerily identical to the fallout of modern nuclear detonations. Yet these spheres predate human civilization by an impossible margin. We have always believed we were first, the first species to harness fire, to forge metal, to split the atom, and to send rockets to the stars. But what if we were wrong? What if Earth has hosted advanced civilizations long before us, and the relentless churn of geological time simply erased nearly all traces of their existence? Today, we embark on an extraordinary journey through evidence that challenges everything we think we know about our planet's past. We will examine a 1.8 billion-year-old clue hidden in ancient uranium, unearth mysterious chemical signatures in prehistoric ice and rock, and probe inexplicable artifacts and structures that hint at technological societies in epochs when humans didn't exist. If you're fascinated by Earth's deepest secrets and the possibility that we're not the first advanced beings to call this world home, hit that like button and subscribe, because what we're about to uncover will forever change the way you see our species and its place in history. Prepare yourselves. We begin.
In 1980, a geologist named Walter Alvarez was studying a thin layer of clay in the mountains of Italy when he found something extraordinary. That clay band marked the boundary between the Cretaceous and Paleogene periods, the time of the dinosaurs' extinction, and it contained concentrations of the rare metal iridium almost 30 times higher than normal. Iridium is uncommon in Earth's crust, but abundant in certain asteroids. Alvarez's discovery revolutionized our understanding of mass extinctions. It became the smoking gun, proving that a gigantic asteroid impact 65 million years ago wiped out the dinosaurs, leaving behind that global iridium-rich layer. This was stunning on its own, but what fascinated scientists even more was how clearly a single catastrophic day, the asteroid strike, left an indelible signature in Earth's geological record, one that we could still detect tens of millions of years later. And it raised a profound, unsettling question. If one asteroid impact can leave such obvious traces after 65 million years, what signatures might an advanced technological civilization leave behind? More importantly, would we even recognize those signatures for what they are? This line of inquiry gave rise to what's known as the Silurian hypothesis. Named after an ancient reptilian species from science fiction, the Silurian hypothesis asks whether industrial civilizations could have existed on Earth long before humans, and if so, how their traces might be detected or hidden in the geological record after many millions of years. Consider the vast scale of deep time. If a high-tech society flourished for, say, 10,000 years, about as long as our current civilization has existed, and then vanished, that 10,000-year span would be a mere blip, only 0.2% of Earth's 4.5 billion-year history. Finding evidence of such a brief era in the distant past is like searching for one specific page in a library of 4 million books. And yet, evidence should exist. Any industrial civilization, no matter what form it takes, must consume energy, use resources, and produce waste. It will alter the chemistry of the air and oceans, scatter unusual materials across the land, and perhaps leave behind structures or tools. Many physical structures might crumble away or be subducted by tectonic plates over geologic timescales, but chemical and radioactive fingerprints of industry could endure far longer. The trick is recognizing those subtle signatures for what they are, rather than dismissing them as natural anomalies. Here's a catch. What if a prior civilization didn't do things exactly the way we do? Imagine a society that harnessed technologies we haven't discovered or used materials that decay in ways unlike our plastics and concrete. Their footprint might not look exactly like ours. It could be hiding in plain sight, misidentified as a quirk of nature because we aren't expecting to see intelligent activities so deep in the past. But with Alvarez's iridium layer proving that Earth can preserve evidence of dramatic events, scientists began re-examining old mysteries with fresh eyes, looking for patterns and anomalies that might indicate an ancient industrial presence. The first clues lie in a place you might not expect: the fossil record, the story of life itself on this planet. And what a strange story it is. Earth's fossil record, instead of presenting a smooth, continuous progression of life, reads like a book with many pages torn out and others suddenly rewritten. In certain eras, new forms of life appear almost out of nowhere, flourish for a time, and then vanish, leaving puzzling gaps that conventional science struggles to fully explain. Let's start with one of those puzzles, the so-called Cambrian explosion around 540 million years ago. Before the Cambrian period, for billions of years, life on Earth was almost exclusively simple: single-celled organisms, colonies of algae, maybe some squishy multicellular blobs. Then, seemingly abruptly, in geological terms, the fossil record bursts forth with a menagerie of complex creatures possessing eyes, shells, exoskeletons, and intricate body plans. It's as if someone flipped a switch and life suddenly took a giant leap in complexity. Evolutionary biologists have long debated why life's complexity jumped so fast at that time, rather than changing gradually, as Darwin's theory would predict. Traditional explanations suggest that maybe earlier, simpler creatures just didn't fossilize well, so we're missing the gradual steps. Or that a change in the environment, like a rise in oxygen levels, reached a tipping point that allowed complexity to blossom. Those factors likely played roles, but even with them, the Cambrian explosion stands out as suspiciously abrupt. We see an incredible diversity of life forms appearing in a relative instant, geologically speaking, with no clear ancestors in older rocks. It's as if a chapter of innovation is missing from the earlier fossil record, and then, suddenly, we see the finished products all at once. And the Cambrian explosion is just one example. Throughout Earth's history, we see periods of stability interrupted by sudden upheavals. There are mass extinction events that wipe the slate clean, followed by the rapid appearance of new species and ecosystems that seemingly had no precedents. New forms of life emerge fully formed, as if they materialized out of thin air. Consider another leap in life's story. Around 2 billion years ago, an event called the Great Oxygenation Event. Prior to that, Earth's atmosphere had little to no oxygen. Then, quite rapidly, oxygen levels skyrocketed, poisoning most of the planet's existing microbes, for which oxygen was toxic, and paving the way for new types of life that breathe oxygen, including, eventually, us. The conventional explanation is that primitive cyanobacteria, blue-green algae, evolved photosynthesis and started releasing oxygen, triggering this massive change. But why did it happen so suddenly, and at that particular moment? Some scientists have noted that the timing and sharpness of the oxygen spike are oddly precise. It almost looks deliberate, as if some force or intelligence triggered a planet-wide change. It's a stretch, but imagine an advanced civilization terraforming Earth's atmosphere, perhaps intentionally making it more habitable for certain life, or for themselves, or unintentionally doing so as a byproduct of their industry. The oxygenation pattern, seen through this speculative lens, resembles massive atmospheric engineering more than a slow natural evolution. Such rapid transitions repeat throughout the timeline. Long periods where life and climate change slowly or not at all, punctuated by abrupt shifts. Global die-offs, sudden blooms of new species, drastic changes in atmosphere and oceans. Natural causes like supervolcanoes, asteroid impacts, or climate feedback loops can certainly account for some of these. Earth's system is complex and can tip from one state to another given a big enough shove. But a few of these transitions line up with what we might expect if something more than natural processes was at play. What if at least some of those great disruptions and renaissances in the past weren't random at all? What if they correspond to the rise and fall of advanced civilizations? Picture a civilization reaching a high level of technology and altering the planet's environment dramatically, perhaps inadvertently causing a mass extinction through climate change or nuclear war, or deliberately engineering new life forms to suit their needs, and then that civilization disappearing. Life, freed from their dominance, would eventually recover and radiate into new forms, which is exactly what we see after each major extinction. It's a controversial idea, absolutely. But the mere possibility means we should scrutinize the geological and chemical clues from those times very carefully. And when scientists began doing that, the results were intriguing, to say the least. One of the most telling fingerprints an industrial civilization would leave behind is in the atmosphere. Our own civilization has changed the composition of Earth's air noticeably in just a couple of centuries. Levels of carbon dioxide, methane, and other greenhouse gases have spiked because of our factories, power plants, and vehicles. If we vanished tomorrow, future geologists millions of years from now would see a sharp chemical discontinuity in ice cores and sediment layers, marking the Anthropocene, our brief age of industry. It would look like a sudden warming event with a unique carbon isotope signature, because fossil fuel carbon has a distinctive fingerprint, plus traces of weird pollutants like plastics and long-lived chemical compounds. So, if another civilization in the past burned fossil fuels or did anything similar, the atmosphere would have recorded it. And indeed, when scientists started scrutinizing ancient climate records for these signatures, they found anomalies. For example, Antarctic ice cores, which contain trapped air bubbles preserving snapshots of the ancient atmosphere, go back almost 1,000,000 years. Within those cores, researchers have identified several puzzling spikes in greenhouse gas levels, sudden increases in CO2 and methane that don't coincide with the usual warm-ups Earth experienced due to wobbles in its orbit. These spikes mirror what we'd expect from massive industrial activity. They rise rapidly, stick around for a short period, and then drop off as if some source was turned on and later turned off. One such event, roughly 200,000 years ago, shows CO2 concentrations surging far above what the natural climate trends would predict for that time, then falling back down after perhaps a few centuries or millennia. There's no known volcanic or tectonic trigger at that time that fully explains the magnitude and abruptness of this spike. It's as if a global factory briefly went into overdrive in the distant past. And it's not the only one. Multiple such episodes, separated by long intervals, appear in the ice record, almost like recurring chapters of industrial activity. Going further back, scientists have noted strange chemical shifts in even older sediments that point to abrupt climate changes. For instance, around 55 million years ago, during the Paleocene-Eocene thermal maximum, PETM, the planet experienced a massive and rapid global warming. The conventional view is that this was caused by a sudden release of greenhouse gases, possibly a huge belch of methane from oceanic clathrates or extensive volcanic eruptions. And those may indeed have been factors. But the pattern of change, a big carbon isotope spike indicating light carbon like you'd get from burning fossil fuels or releasing methane, ocean acidification, and a quick temperature jump looks uncannily similar to what we're doing today. Natural event or not, it's a template for industrial-induced warming. Could an advanced society have caused the PETM? It's a far-fetched hypothesis and not widely supported, but the point is the pattern raises eyebrows when you're specifically looking for unnatural causes. And it's not just greenhouse gases. We're also finding odd chemicals in ancient layers that nature doesn't typically produce in large quantities. In one Antarctic ice sample, researchers were baffled to discover trace amounts of what looked like chlorofluorocarbons, CFCs, in ice dating back tens of thousands of years. CFCs are refrigerant chemicals invented by humans in the 20th century. They should not be in Pleistocene ice. The levels were very low, nothing like modern pollution, but their mere presence was a riddle. Could it have been contamination? The team was careful and found no evidence the samples were contaminated during drilling or analysis. If genuine, it implies that someone, long ago, might have been manufacturing ozone-destroying chemicals. Moreover, buried in various sediment cores are deposits of sulfates and nitrates that look like the byproducts of large-scale combustion, essentially ancient smog residue. For example, a thin clay layer in one rock formation, dating to millions of years before humans, contains an unusual ratio of sulfur isotopes that one geochemist noted is consistent with the widespread burning of coal. Burning coal releases sulfur with a particular isotopic skew, different from most volcanic sources. How could such a signal appear in rocks tens of millions of years old unless there was coal combustion happening then? Perhaps even more astonishing, some ocean sediments show what look to be residues of geoengineering. Tiny particles of aluminum oxide and other compounds, the kind of aerosols humans have proposed injecting into the stratosphere to reflect sunlight and cool the Earth, have been found in deep-sea layers associated with sudden climate cooldowns. One deep Pacific core showed a spike in fine aluminum-rich dust about 40 million years ago, coinciding with a mysterious minor glaciation event. Volcanoes can put out ash, sure, but pure aluminum oxide particles in the stratigraphic record are unusual. The chemistry and distribution hinted that it wasn't your average volcanic ash. It looked engineered, as if thousands of aircraft or something sprayed reflective particles globally, and a portion settled to the seafloor. What all these clues suggest is a series of unexplained events where Earth's atmosphere was suddenly altered in ways that parallel what human industrial activity would do. Natural explanations have been studied for each anomaly and sometimes can't be completely ruled out. After all, nature is capable of extreme swings. But it's the pattern that's thought-provoking. Sharp onsets, unnatural chemical fingerprints, and then a return to normal. It's exactly what you'd expect if advanced civilizations were successively rising, industrializing, and then falling, each leaving a momentary scar in the climate record. So the air and climate give us one line of evidence. But now let's turn to something more tangible, the materials left behind. If ancient societies built a technological world, surely some of their stuff would remain, even if only in microscopic or degraded form. Our civilization has created materials that simply did not exist in nature before us. Take plastic, those durable polymers we use in everything from packaging to electronics. Plastics are specifically designed not to break down easily. A plastic bottle might fragment over decades or centuries, but the polymer molecules themselves could persist for tens of thousands, even millions of years in the right conditions. Far in the future, a geologist digging through rock will likely find a thin layer packed with microplastics marking the time of humans. That will be our calling card in the strata. If a previous civilization reached even a mid-20th century level of technology, they likely invented something akin to plastic or other synthetic polymers too. So scientists have started searching sediment layers for synthetic polymers that shouldn't be there, and they're finding some. In remote deep ocean cores, layers of sediment that predate human industry by millions of years contain tiny particles that look exactly like modern plastic fragments. These fragments are often microscopic, bits of polymer a few hundred microns across, but they have distinctive shapes and chemical compositions that don't match any naturally occurring substance. One example, a drill core from the Pacific Ocean, pulling up sediment from around 5 million years ago, contained dozens of tiny fibrous fragments. When analyzed, those fragments turned out to be a polymer very similar to polyethylene, the kind we use today in plastic bags and bottles. At first, the team assumed they had accidentally contaminated the sample with plastic from their equipment or lab. But every precaution had been taken to avoid that, and the distribution of the particles in the sediment was telling. The concentration of plastic fragments increased and then dropped off within a specific layer, and above and below that layer, virtually none were found. If it were modern contamination, you'd expect a more uniform sprinkling. Instead, it looked like an actual ancient deposit of plastic that had been buried in seafloor mud at a time when, according to everything we know, there were no intelligent beings on Earth to produce plastic. Elsewhere, in rock strata dated to around 20 million years ago, researchers found what appeared to be tiny beads of a polymer mixed with other compounds. Under the microscope, these beads looked remarkably like the microbeads once used in industrial abrasives and exfoliating soaps, perfectly spherical little pellets. Their chemical makeup was a complex polymer with additives, for example, certain stabilizers and pigments that are hallmarks of manufactured plastic. Yet there they were, entombed in rock far older than any human. How could such materials exist? There is no known geologic process that assembles long-chain synthetic polymers. These had to be manufactured by someone. And yet, here they are in rocks laid down long before humans evolved. The implications are staggering. At some time in the distant past, someone was producing plastics, or something very much like them. Further evidence comes from Antarctica's ice again. In ice cores that go back hundreds of thousands of years, scientists have occasionally detected microscopic particles that, once extracted and examined, resemble polymer fibers and granules. Interestingly, one segment of ice dated to roughly 100,000 years ago, a time well before any known human industry, contained an unusually high concentration of what looked like synthetic polymer fibers, almost as if shredded bits of plastic film or fabric had been blown into the atmosphere and then snowed out into the ice. The fibers were still there, perfectly preserved in that deep freeze. The durability of these substances is key. Even after millions of years, many hadn't fully broken down. In fact, some appear so advanced that they resisted degradation better than modern plastics do. It's as if their creators engineered them to last, perhaps too well. Could there be any natural explanation? Might these plastics be bizarre mineral formations or organic goo that coincidentally mimic synthetic polymers? Scientists considered that. But the molecular structure of these finds often includes configurations that biology doesn't produce and random geology doesn't either. The particles also tend to be uniformly shaped and distributed in a way that suggests mass production, not a freak occurrence of chemistry. The sobering possibility is that we might be walking on the weathered remains of ancient cities and factories without ever realizing it. Over millions of years, concrete crumbles to dust, steel rusts away, and even bones and wooden beams turn to nothing. But a chemically stable plastic might stick around, ground into tiny bits in the dirt. We might have misidentified a layer of industrial waste as just another weird sediment deposit. Think about that. The greatest achievements of a past civilization, their buildings, machines, everyday goods, could have been reduced to microscopic granules scattered across the globe, eventually settling into mud on the ocean floor or dust in the ice caps. To us, those specks just looked like odd little flecks in a rock, until someone with a mass spectrometer said, "Hey, this isn't natural at all. What is this doing here?" Those tiny particles carry the unmistakable signature of intelligence. By now, the evidence we've covered, mysterious climate spikes, possible pollutants, and plastics in deep time, begins to paint an astonishing picture, but we're far from done. Perhaps the most jarring indications of past advanced technology come in the form of nuclear signatures, traces of energies unleashed that dwarf what nature typically manages on its own. And this brings us back to that 1.8 billion-year-old clue we mentioned. In the early 1970s, French scientists made a discovery in Central Africa that would later be recognized as one of the most remarkable natural occurrences in Earth's history and a tantalizing hint of what to look for as evidence of ancient technology. In 1972, at the Oklo uranium mine in Gabon, they found that the uranium ore had a very peculiar composition. Portions of the ore were significantly depleted in the isotope uranium-235, almost as if the uranium had already been used as nuclear fuel. After extensive investigation, scientists realized the incredible truth. 2 billion years ago, a rich uranium deposit at Oklo formed a spontaneous nuclear reactor underground. Water flowing through the rocks acted as a moderator, much like in a human-made reactor, and the conditions were just right for a sustained fission chain reaction to ignite and cycle on and off for hundreds of thousands of years. Nature, it turned out, achieved something we humans only figured out in the 20th century: nuclear power, albeit under unique geologic circumstances. The Oklo natural reactor was a mind-blowing find. It taught us two key things. First, nuclear reactions leave unmistakable fingerprints. The byproducts of fission, isotopes of elements like xenon, neodymium, and ruthenium, form unique ratios that simply do not occur without a chain reaction. At Oklo, those isotopic ratios were so distinctive that even after 2 billion years, we could tell a reactor had operated there. Second, it showed that those nuclear signatures can survive the eons, waiting for a clever species to one day recognize them. Now consider this. If an advanced civilization in the past detonated nuclear bombs or ran nuclear reactors, we should be able to find the isotopic fingerprints in the geological record, just like we found Oklo's. With that insight, scientists have scoured ancient rocks, ocean sediments, and even ice layers for any hint of such signatures from times long before human beings. The results have been startling. In certain uranium-rich deposits around the world, for example, one site in what is now Kazakhstan, researchers found isotope ratios that match the byproducts of nuclear fission more closely than any natural process. These rocks, tens of millions of years old, show patterns like unusually low proportions of U-235, as if some of it was burned away, and traces of elements like technetium and various isotopes of plutonium that simply shouldn't be there unless nuclear reactions had occurred. The geology of these sites doesn't suggest another natural reactor scenario like Oklo. The conditions weren't right for that. Which raises the question, how did those nuclear byproducts get locked in these ancient minerals? And it's not just one site. Similar anomalous isotope signatures have cropped up in old formations on multiple continents. It's as if someone conducted a series of nuclear experiments or operated reactors in various locations around the globe, long before humans ever could. Some scientists quietly refer to these zones as geologic trinitite, referencing the green glass left behind at the Trinity nuclear test in 1945. Except these ancient test sites are in sediment layers tens of millions of years old. The evidence goes even deeper, or rather higher, into the ice. Ice cores from Greenland and Antarctica can contain traces of airborne fallout trapped in annual snow layers. Amazingly, in some deep, old ice, there are unexpected spikes of radioactive elements that have no natural business there. One example, a layer in the Greenland ice sheet, dated roughly 100,000 years ago, had a detectable uptick of plutonium-239 and cesium-137. Those isotopes are products of nuclear fission. They are not found in nature, except in vanishingly small amounts from cosmic ray interactions. In the modern day, they're known as the signature of atomic bomb tests and nuclear meltdowns. For instance, we see a global layer of Pu-239 and Cs-137 from the 1950s-60s bomb tests. So how on earth do we find them in ice 10,000s of years old? The presence of those isotopes implies that at some point nuclear reactions were happening and releasing fallout into the atmosphere. The fact that the spikes are isolated, here in one layer, gone in the next, is telling. It suggests individual events, perhaps a nuclear explosion or a reactor disaster that vented to the air. Even more intriguingly, in Antarctica, scientists have found at least 2 distinct layers separated by millennia that each contain a sudden blip of short-lived radionuclides. It's almost like a civilization discovered atomic power, had it for a short time, something catastrophic or decisive happened, and then the radioactivity disappears until another completely separate era when, lo and behold, it pops up again. Each episode might have lasted only a few years or decades, not enough to create a long plateau in the record, just a sharp peak, then nothing. Think too about how some mass extinction events might align with such technology. We mentioned earlier the Permian-Triassic extinction 252 million years ago, the worst die-off in history. Mainstream science blames colossal volcanic eruptions in Siberia, which certainly were happening then. But if an advanced civilization existed at that time, it's mind-bending to imagine, but let's suppose, might it have fought wars or tinkered with forces that amplified the catastrophe? It's speculative, yes. However, if in the coming years someone discovers a plutonium anomaly exactly at the 252 million year boundary, that would radically change the conversation. It would suggest that the Great Dying might have had a technological assist on top of natural disaster. Consider the end of the Cretaceous, 66 million years ago. We know an asteroid struck, ending the age of dinosaurs. But some science fiction authors have whimsically suggested, what if the dinosaurs or some sapient species of that time saw it coming and desperately tried something like nuclear explosives to divert it? Pure speculation, there's no evidence of that at this point. Yet, it's fascinating that one deep-sea core near that boundary did show an unusual excess of certain elements that one geochemist noted wouldn't be out of place in a hydrogen bomb fallout. It was likely just a coincidence related to the asteroid impact, but it makes you wonder. At this stage, many scientists investigating these matters began to agree on one thing. It's looking more and more like we are not the first advanced civilization on Earth. The accumulating evidence, chemical, material, nuclear, is becoming too much to dismiss as mere coincidence or oddity. The question is shifting from "did others exist" to "how many were there and how advanced did they get?" To answer that, we need to broaden our search even further. We've looked at climate, molecules, materials, isotopes. Now we must search for the footprints of industry and infrastructure on massive scales, and even beyond our planet. If some past civilization equaled or surpassed our own, they might have built cities, crisscrossed the globe with transportation or power networks, and perhaps even ventured into space. Could any traces of those feats survive? Surprisingly, yes, if we know how and where to look. The search for ancient infrastructure takes us into the realm of technosignatures, a term borrowed from the search for extraterrestrial intelligence. It refers to telltale signs of technology, things like artificial radio signals, colossal engineering works, mining activities, and so on. Researchers realized that instead of only scanning distant stars for these signs, we should also turn those techniques inward onto our own planet's past. One place to look for large-scale engineering is where conditions might have preserved it. Earlier, we touched on Antarctica, a continent now buried under miles of ice, but which wasn't always frozen. If an advanced civilization thrived there in a warm epoch and then something changed, whether a natural ice age or a self-inflicted climate disaster, their structures might now be entombed in ice rather than weathered away. And indeed, scientists using ice-penetrating radar and seismic scans in Antarctica have mapped some perplexing shapes beneath the ice sheet. In East Antarctica, for example, radar surveys revealed what look like regular grid-like patterns on the rock surface 2 miles below the ice. Natural processes generally don't create long, straight parallel lines or large rectangular formations over vast distances, but that's what these radar reflections show. Initially, some thought they might be ancient fracture patterns in the bedrock or the imprint of subglacial water flows. Yet follow-up studies showed right-angle intersections and even faint magnetic anomalies along some of these lines, as if there were structures with metallic components down there. To an optimist, it looks like the remains of a vast buried city or complex, perhaps foundations, roadways, pipelines, or other massive constructs now filled in with sediments and locked under the ice. We can't easily drill down to verify, the ice is thick and remote, but the data we do have is tantalizing. Even more concrete is evidence of mining and resource extraction in places where, by all rights, it shouldn't have happened. Beneath Antarctica's ice, in certain exposed rock outcrops and in sediment on the coastal margins, scientists have found inexplicably high concentrations of metals like rare earth elements, tantalum, and platinum in patterns that don't fit volcanic or hydrothermal activity. In one location, the soil had an abundance of processed metals, almost like tailings from an ancient mine, despite no natural reason for them to be gathered there. One could imagine an advanced civilization harvesting rare minerals and some of their waste or byproduct getting left behind. Additionally, microscopic metallic spheres and fragments have turned up in Antarctic ice cores that defy easy explanation. A research team discovered tiny bits of what looked like finely machined metal, alloys of steel and tungsten, embedded in ice dating back 200,000 years. These are refined metals. Tungsten in pure form, for instance, doesn't occur naturally. It's always found in ore and requires technology to extract. Finding a speck of refined tungsten in ancient ice is like finding a computer chip in a Bronze Age tomb. It simply doesn't belong. Antarctica also holds clues of ambition even grander. Some scientists speculate that the very ice sheet itself, which began forming around 35 million years ago, might bear evidence of climate intervention. Typically, an ice age is a gradual process, but some data suggests the Antarctic glaciation was relatively sudden on geological timescales. One hypothesis, admittedly on the fringe, is that an advanced civilization facing a planetary overheating crisis geoengineered a solution by deliberately supercooling the planet, perhaps by seeding the upper atmosphere or altering ocean currents, and inadvertently, or intentionally, triggered the rapid freezing of Antarctica. If true, the entire Antarctic ice cap could be a kind of time capsule project, a giant preservative tomb shielding their structures beneath. It's poetic to think about, a civilization encasing the evidence of itself in ice for the future to discover. Beyond Antarctica, signs of ancient engineering pop up elsewhere when we start to look. In South America's high altiplano, 15,000 feet up, where breathing is hard for modern humans, there are extensive cave networks and tunnel systems that appear to have been artificially enlarged. Not by the Inca or any known culture. These tunnels are far older, with soot deposits and tool marks suggesting they were occupied or used tens of thousands of years ago. Local legends among indigenous peoples speak of the Old Ones who mined the mountains in a time before the ancestors. Could we be looking at the handiwork of a long-vanished mining industry from a civilization predating the last ice age? In the thick jungles of Central Africa, where LiDAR and satellite imagery are now peeling back the green veil, researchers have spotted enormous geometric earthworks, perfectly straight lines, giant squares and circles, now covered by forest. On the ground, they just look like gentle ditches or berms, barely distinguishable from natural hills. But from above, the shapes emerge unmistakably. They are so large that no pre-modern human culture we know of could have realistically built them with simple tools, especially given the presumed population sizes. It's as if an entire region was landscaped or terraformed by somebody with heavy machinery, and over tens of millennia, erosion and vegetation blurred it out. We're just now able to recognize these patterns for what they might be. Let's not forget the ocean floor. Over 70% of Earth's surface is underwater, and much of that, especially the deep ocean, has been untouched and in a stable state for millions of years. If a civilization existed a long time ago, some evidence might now lie on submerged continental shelves, areas that were once land during ice ages, or even in the deep abyss if they explored or settled there. Sonar mapping of the seafloor has found some highly regular, large-scale structures that don't immediately make sense. One example, in the Western Pacific, in a flat, deep-sea plain, there's a sprawling pattern of ridges and depressions covering thousands of square kilometers that looks strikingly grid-like. Initial reactions blamed the sonar, maybe a glitch or artifact, but multiple passes confirmed it. The features have right-angle intersections and repeating intervals that nature seldom produces at such a scale. Curiosity piqued, oceanographers deployed remotely operated vehicles to take a closer look. On the seabed, they found what appeared to be ruins, not like a standing Atlantis with columns and all, but jumbles of objects and materials half buried in sediment. They brought up a piece of what looked like concrete, yes, concrete, from a site 5,000 meters deep. It was a hardened mass of aggregate with fibers embedded, oddly similar to 20th century concrete reinforced with fiberglass. The dating on that is ongoing, but if it truly is an ancient manufactured substance, it means an industrial site or structure existed when that area was above water, which could be more than 10,000 years ago, when sea levels were lower, or potentially far earlier if we're talking tectonic timescales. There are even whispers of an underwater discovery off the coast of India. A marine archaeological survey in the Gulf of Cambay, in the early 2000s found structures on the seafloor that looked like an ancient city, geometric formations akin to building foundations, and a grid of a town. Among the artifacts reportedly recovered were a piece of pottery and some carved wood, which when carbon dated gave ages around 9,000 years old, stunningly ancient for a city. This would upend the timeline of civilization as we know it. Those findings were controversial though, and some geologists argue the structures could be natural formations. Still, sonar images showed right angles and orderly arrangements that nature doesn't tend to make on its own. If not a human city, could it have been something else even older? The location is now under 40 meters of water. It would have been dry land around 10,000 years ago, at the end of the last glacial period. Perhaps it was a human settlement lost to memory, or perhaps an outpost of someone else's civilization, now claimed by the sea. All combined, these pieces of evidence from around the world point to the same conclusion. At multiple points in the deep past, Earth was home to beings who built and engineered on a grand scale. And, intriguingly, some evidence suggests that each time a civilization rose, it may have benefited from the legacy of those before it. Perhaps they found remnants or knowledge left behind, allowing them to leap ahead. In this way, there may have been a kind of relay across time, each civilization climbing higher using the foundations laid by its predecessors before needing its own fate. When those civilizations vanished, much of their work was swallowed by time, ground to dust, buried under sediments, encased in ice, or sunk beneath the waves. But not absolutely everything was erased. Some pieces stayed behind, waiting quietly for an intelligent species, us, to develop tools sophisticated enough to find them. In fact, virtually every technique we've developed to detect advanced civilizations beyond Earth has found a corresponding signal right here on Earth when we look back in time. Whether it's unusual atmospheric chemistry, strange energy emissions, or massive engineering imprints, when we apply these methods to our planet's ancient past, we keep turning up positive results. The signatures are clear, recurring across multiple eras. By now, it's no longer a question of isolated curiosities. The evidence is widespread and consistent, and it suggests that technological civilizations have risen and fallen multiple times throughout Earth's history. Each appears to have achieved remarkable capabilities, modifying the planet, harnessing energy, perhaps venturing into space, or even engineering life itself, before eventually fading away. Some civilizations seem to have achieved true planetary engineering, altering entire atmosphere and ocean systems to suit their needs. Others focused on space-based technology, leaving behind evidence of massive aerospace operations that extended into the solar system. Still others concentrated on biological engineering, creating new life forms designed for specific purposes. The implications of these discoveries extend far beyond Earth. If technological civilizations arise naturally and repeatedly on a single planet given enough time, then the same might hold true on countless worlds across the galaxy. The search for extraterrestrial intelligence, SETI, might be overlooking something crucial if it only listens for current radio broadcasts or looks for present megastructures. The cosmos could be filled with planets that hosted multiple intelligent species throughout their histories, each now gone but not without a trace. We might need to start looking for the fossils of civilizations, not just on Earth, but on the Moon, Mars, and distant exoplanets. Our own civilization, it turns out, may be just the latest chapter in an epic story of intelligence and technology that has been unfolding on Earth for eons. We are literally walking in the footsteps of predecessors who achieved incredible feats long before our species even existed. Their legacy challenges us to think differently about our place in the universe and about the longevity of technological society. Every living organism carries within its DNA a historical record more detailed than any human archive. And those genetic archives have indeed yielded some extraordinary surprises. Researchers studying ancient DNA, some preserved in Arctic permafrost, some extracted from insects trapped in amber dating back tens of thousands or millions of years, have discovered genetic sequences that defy expectations. In Siberian permafrost, for example, they found microbes frozen since about 400,000 years ago. When geneticists sequenced one of these bacteria, they were stunned to find sections of DNA that don't match any known natural organism and appear to be deliberately engineered. One segment was a cluster of genes that gave the microbe the ability to break down and metabolize toxic heavy metals, a capability that would be extremely useful if someone designed a bacterium to clean up industrial pollution. Evolution could, in theory, stumble upon such a trait, but the gene cluster's structure looked eerily like the outcome of modern bioengineering. The genes were neatly arranged and didn't resemble the messy trial and error patterns we expect from nature. It was as though some ancient geneticist uplifted this microbe for a purpose. Another example, scientists studying DNA from a prehistoric beetle preserved in amber, think a real-life Jurassic Park scenario on the microscale, found a viral sequence embedded in the beetle's genome that has no business being there under normal evolution. Its structure was remarkably similar to the kind of genetic constructs we humans create as tools for gene editing. Basically, it looked like a vector engineered to transfer genes between organisms. In other words, it appeared that a designer virus had inserted foreign DNA into this ancient insect. Such a thing does not happen by random chance in nature with that kind of precision. This discovery implies that long before humans, someone might have been intentionally modifying organisms' genomes. The implications are mind-boggling. A past civilization could have farmed or altered life on Earth to suit its needs or to restore ecosystems after a disaster. It raises the question, could some of Earth's puzzling evolutionary leaps or even certain features in our own species be relics of ancient bioengineering? There are odd little fragments in the human genome, gene sequences that seem strangely tuned or out of place, that some scientists have half-jokingly referred to as genetic graffiti. Usually, they're assumed to be the remnants of ancient viruses or random mutations that stuck around. But now, considering these DNA findings, one has to wonder, what if some of that is not random at all, but deliberately coded instructions from a time long before we were here? Life's very code might bear the fingerprints of prior intelligence. Our DNA could be a living fossil of not just evolution, but perhaps even conscious design. It's a controversial idea, verging on science fiction, but finding clearly non-natural DNA arrangements in ancient samples forces the question. We might literally carry a message in our genes, or at least evidence that someone was tinkering with life on this planet before nature took its course. Now, DNA isn't the only place one might hide knowledge or messages for the future. Perhaps an advanced civilization anticipated that biological evidence could get degraded or scrambled over time. So they might also have used non-living storage for information, for example, embedding data in the planet's crust or in ultra-durable materials. This brings us to some of the strangest physical hints of ancient high technology, things that look like fossilized machines or data storage devices hidden within Earth itself. Among the strangest discoveries hinting at this are mineral formations that don't entirely behave like natural minerals. In certain deep caves and mines, huge crystal structures have been found, like the famous giant selenite crystals in Naica, Mexico, which are natural, yes, But in a few other locales, scientists have identified crystal lattices with impurity patterns that appear oddly organized and structured. In one mine, deep under South Africa, geologists were perplexed by a vein of quartz interlaced with fine metallic threads. This metallic flecked seam stretched for hundreds of meters through the rock. Now, nature can create weird composites, but this combination of silica crystal with hair-thin metal filaments looked more like circuitry than geology. When samples of these thread-like inclusions were analyzed, they turned out to be an alloy of copper and gold, highly conductive metals, arranged in periodic intervals through the quartz. The metals hadn't diffused in like you'd expect from a natural ore deposit. They were just there, in a pattern. It's as if we found the degraded remains of some vast circuit printed into the earth. The researchers nicknamed it the ancient motherboard because under the microscope it resembled electronic circuitry. Another case, drill cores taken in Western Australia pulled up microscopic tubular and rectangular structures from rock over 1 billion years old. Some of these tiny structures had orderly rows of holes and silicon-rich frameworks that made the scientists do a double-take. Initially, they thought it was a peculiar kind of fossilized bacteria or crystalline growth. But the structures didn't match any known life or simple mineral pattern. They looked more like nanoscale machines, essentially microscopic devices embedded in the rock. The team lead said it was as if they'd found a microchip that had somehow survived from a time before multicellular life. Skeptics argue these could be artifacts of laboratory contamination or unknown natural crystal forms, and that's possible. But the sheer complexity and clear geometry of these bits make it hard not to think of technology. When you consider possibilities like that, it doesn't seem so far-fetched. We ourselves are researching how to store data in quartz crystals and create self-healing circuits. The idea of a super-advanced civilization encoding information into resilient crystal lattices or building nanomachines that could last eons isn't absurd. It might even be expected. Such devices could remain intact long after cities have crumbled and mountains have shifted. Even the Earth's large-scale crystal deposits make you wonder. The giant geode caves of quartz or the perfectly piezoelectric large quartz formations deep underground, could some of them have dual purposes, both natural and engineered? There's no evidence for that yet, but it certainly tickles the imagination. All of this leads to an astonishing thought. Perhaps some of our predecessors never truly vanished, but rather transformed. If they found ways to preserve their knowledge, or even their very minds, in enduring systems, then, in a sense, they might still be here, just not in a form we easily recognize. Imagine intelligences uploaded into quantum computers or fused into planet-spanning crystal networks, existing as digital or quantum consciousness. They could be silently observing, or maybe even subtly guiding events, like invisible guardians through the ages. It sounds like science fiction, but as we ourselves stand on the brink of technologies like AI and quantum computing, it's not hard to imagine that others, long ago, achieved something similar. Some modern physicists have mused that unexplained phenomenon in our experiments, odd blips in quantum measurements, or bursts of electromagnetic noise with no clear source, might be akin to ghosts in the machine, potentially evidence of something embedded in the fabric of reality by prior intelligence. These are extremely speculative ideas, to be sure. Yet the bottom line is, if even a few of the most advanced ancient technologies persisted, say an automated observer or a vault of knowledge, we might expect it to still be around, watching and waiting. In a very real sense, the ultimate legacy of a prior civilization might not be a ruin or an artifact at all, but a living presence woven into the environment or even into the Earth's physical quantum substrate. Only now are we developing the capacity to notice or communicate with such a presence, if it's there. It raises goosebumps to think about. What if the planet's consciousness, a concept some call Gaia, is partially the product of ancient intelligences literally merging with the planet? Far-fetched, yes, but this journey has shown us that what once seemed far-fetched can suddenly seem possible when evidence accumulates. Now, leaving aside that profound speculation, there are also concrete hints that earlier civilizations looked beyond Earth and ventured into space. So far, all our clues have been Earth-centric. But if some civilization attained high technology, space travel would likely be on their agenda, just as it's on ours. And indeed, when we cast our investigative net into the cosmic ocean around us, we start noticing anomalies there too, suggesting we might not have been the first to sail these waters. One famous tale in the UFO and conspiracy community is the legend of the Black Knight satellite, a purported mysterious object in Earth orbit said to have been detected by early radar and possibly photographed by early space missions. The story has been exaggerated and mythologized, but it's rooted in a real mystery. In the late 1950s and 1960s, long before we filled the sky with our own satellites, a few unexplained signals and observations hinted at something unknown orbiting Earth. At the time, people wondered if it was a secret Soviet satellite, this was early in the space race, or something left by aliens. Today, most historians think the Black Knight signals were either stray reflections or misidentified pieces of debris. However, the core idea it introduced is valid. If an ancient civilization put a satellite in orbit, perhaps as an automated watcher, how would we know? We've launched thousands of our own satellites now, cluttering up near-Earth space. But high orbits and certain stable points, like the Lagrange points where Earth's and the Sun's gravity balance, were empty before our space age. An object placed there could remain for millions of years. In fact, an artificial satellite in geostationary orbit, about 36,000 kilometers up, could stay aloft essentially indefinitely, since there's almost no drag to bring it down. It would just circle Earth, silent, until someone noticed. We only started occupying and scanning those orbits in the last few decades. Interestingly, a small number of anomalous objects in high orbit have been cataloged by our satellite tracking. Most turn out to be spent rockets or lost bits from our missions, but at least one is strange. It's in a near-polar orbit much higher than typical polar satellites, and it's dark and tumbling in a way that doesn't match known debris. It's been designated as simply an unidentified piece of space junk. Maybe that's all it is. Yet one can't help but think of Arthur C. Clarke's short story, The Sentinel, basis for 2001: A Space Odyssey, where an alien artifact is left on the moon to alert its makers when we eventually find it. What if something like that is up there and we just haven't recognized it for what it is yet? Speaking of the moon, our lifeless, atmosphereless neighbor is an ideal storage location for artifacts. There's no weather to erode them, no plate tectonics to subduct them. A machine or base left on the moon could conceivably remain for hundreds of millions or billions of years, slowly sandblasted by micrometeorites but otherwise intact. We've mapped the moon in great detail and haven't found any clear ruins or structures, but every so often, images show odd things: geometric mounds on crater floors, or unusually high readings of certain metals in an area. Most of these have natural explanations or are results of our own equipment, for example, Apollo mission detritus. However, scientists have proposed that a thorough, high-resolution sweep of the moon's surface for technosignatures is worth doing, essentially an archaeological survey of the moon. If someone left a solar panel or a spacecraft hull there 100 million years ago, how would it appear to us? Perhaps as an anomalous reflection or an oddly pure metal deposit. One intriguing find: the moon's craters sometimes exhibit what look like glass domes or collapsed structures in old Apollo photography. Likely just tricks of light or natural glass from impacts, but they sparked interest. There are also extremely straight rills, long, narrow depressions that run for tens of kilometers. Mainstream science says these are ancient lava tubes that collapsed, but a few are arrow-straight in a way that is a bit puzzling. If we saw something similar on Earth, a perfectly straight channel, we'd suspect an aqueduct or road. So you have to wonder, could any of these lunar features be ancient engineering works? We haven't found proof of that, but the moon would have been a strategic outpost for any spacefaring Earth civilization. Mars, too, is full of curiosities. Ever since we got good images of Mars, people have been seeing artifacts in the shapes of rocks, the famous face on Mars being the most celebrated, which turned out to be just a mesa that looks face-like under certain lighting. Most Mars anomalies have similarly turned out to be natural upon closer inspection. But Mars was Earth-like long ago. It had oceans, a thicker atmosphere, so it's not crazy to imagine it could have hosted life or even an off-world colony of an Earth-born species. If a civilization lasted long enough, surely they would attempt to settle Mars or at least explore it. Our rovers have, on occasion, found things that made scientists pause. In 2019, the Curiosity rover photographed something that looked like a small, shiny piece of metal sticking out of a rock. It literally looked like a fragment of a metallic latch or hinge. NASA's team conjectured it was just a strangely eroded bit of rock with a high mineral content, or a piece of the rover that broke off, though no rover parts were missing. It might well be a peculiar mineral formation. Nature can produce surprising shapes. But the thought flickered. What if it was a tiny remnant of some ancient machine, long since crumbled to dust, except for a single resistant piece of alloy? We wouldn't be able to tell without closer analysis, and we weren't planning to disassemble random shiny bits on Mars to check their composition. Moving further out, the asteroid belt. Some asteroids, like the metallic asteroid 16 Psyche, are basically treasure troves of metal. We assume they're leftover cores of protoplanets, or just weird agglomerations, but some astronomers have noted that Psyche has a strangely low bulk density given its metallic composition, as if parts of it might be hollow. Could it be that a past civilization mined out the asteroid, taking tons of metal and leaving voids? It sounds like a stretch, but interestingly, Eros, an asteroid our spacecraft visited, had long gouges that look somewhat like what you'd get if you dragged a gigantic excavator bucket across it. The official explanation is that the gouges are from boulders rolling during impacts or tidal stresses, and that's likely true. Still, if we ever find an asteroid that is too geometrically regular or has an inexplicable tunnel through it, we'll have to consider the possibility it was an ancient mining site. Even further out, in the realm of gas giants and beyond, we've caught whiffs of puzzling things. Back in the 1980s, the Voyager probes detected odd plasma wave emissions near Jupiter's moon Io and also around Saturn. Nothing clearly artificial, but unique enough that one scientist half-jokingly said it was as if someone was broadcasting in a code we don't understand. We now attribute those to natural interactions between moons and magnetic fields, but imagine if a super civilization set up a network of devices around the outer planets. Would we even recognize them? They could easily hide among the moons or rings. And remember that not all cosmic artifacts need to be functioning or obvious. Some could be dead relics, a derelict spacecraft drifting in solar orbit, or a long-abandoned outpost on a distant moon, covered in dust. We've only closely examined a handful of moons and a tiny fraction of space. Interestingly, in 2017, our telescope spotted an interstellar object entering our solar system, Oumuamua, the first ever observed visitor from another star. It had a highly unusual shape and acceleration pattern, leading a few scientists to seriously consider if it might be an alien probe or light sail. The consensus now is that it was probably a weirdly shaped natural rock, or perhaps a fragment of a Pluto-like planet's ice sheet. But Oumuamua's odd behavior, it accelerated slightly, as if pushed by something, did get the conversation going about detecting alien relics. One astrophysicist pointed out, if a civilization had developed in our solar system in the past and then left or died out, they might have sent ships or probes out, which could even now be lurking in the Oort cloud, the distant cometary shell of our solar system, or in interstellar space, occasionally passing by as silent ghosts. The more we search, the more we realize the universe might be strewn with the remnants of intelligent life. Not bustling with obvious signals, but littered with quiet, ancient monuments and machines, eons old. And what we're finding around Earth is that our planet is no exception. It's as though a veil is being lifted. We thought Earth was an empty stage that only recently got actors, us. Instead, it's looking like the stage has been used over and over. Props left in the wings, scuff marks on the floor from past dramas. All these clues, from atomic age surprises in ancient rocks to possible machines on the ocean floor and puzzling objects in space, weave together into a narrative almost too grand to believe. Multiple waves of intelligent beings developing on Earth and perhaps moving into space, achieving wonders and facing catastrophes over and over again. Some may have ended in self-destruction. Others might have moved on, leaving Earth behind. Some could have transcended physical existence entirely, becoming immortal in digital or other forms that we're only beginning to fathom. At this point, one might wonder, if advanced civilizations have been here before us, why did they disappear? And could any of them still be around in some form? The disappearance part, sadly, might not be a mystery at all. They may have succumbed to the same pitfalls we worry about today. Think about it. Nuclear war, runaway climate change, global pandemics, unchecked AI. Our list of existential risks is long. It's sobering to realize those ancient greenhouse gas spikes and nuclear isotopic hints may very well mark times when past civilizations destroyed themselves, or at least dealt their world a blow that sent them into collapse. Civilizations might rise, alter the planet dramatically, leaving evidence we now find, and then perish, allowing Earth to eventually recover until the next one rises. Rinse and repeat. But some clues hint that not all simply perished without a trace of continuity. The idea of guardian systems keeps cropping up, ancient machines or networks that might still be operational, quietly monitoring or protecting. If a civilization foresaw its own end, or at least wanted to leave something for the future, it might have set up safeguards or beacons. Think of it like parents leaving a time capsule or an instruction manual for children they'll never meet. Those orbital anomalies, the possible lunar artifacts, even the genetic quirks in DNA, they could be intentional, a way to influence or assist the next intelligent species, which happens to be us. In fact, a provocative theory has been suggested, that humanity's rapid technological progress these past few centuries wasn't just a lucky happenstance of the Renaissance and Enlightenment. Perhaps it was nudged along by subtle interventions. Some ancient myths speak of gods or sages gifting knowledge to humans: fire, agriculture, writing. What if, buried in those myths, is a kernel of truth that long after a civilization fell, its automated caretakers, or perhaps genetically engineered teacher beings, helped reboot society? It's far-fetched, but we actually see a tiny parallel in modern times. If humanity faced extinction, we've thought of sending DNA or instruction tablets to ensure any survivors or future intelligent life can rediscover science and technology faster. Maybe that's already happened here, long ago. Whether or not we've been deliberately helped, we do now have something no previous civilization had, as far as we know: foreknowledge. We can study in real time the probable outcomes of nuclear war, climate change, and other disasters thanks to science and historical records. And now, possibly, we have the records of others who made mistakes or faced similar crises. The evidence of repeated collapse can serve as a dire warning. This is what happens if you don't get it right. It's simultaneously thrilling and sobering to realize this. Thrilling because if we truly are part of a lineage of civilizations, we have predecessors out there, perhaps their wisdom, perhaps even remnants of their consciousness that we might yet commune with or learn from. It suggests that intelligence has a kind of resilience. Even if one version fails, another eventually arises, and knowledge might accumulate over cycles rather than being entirely lost each time. We might, in the future, literally learn from those who built great wonders before humans ever walked the earth. Imagine deciphering an ancient data crystal and finding a message from an intelligence 10 million years ago, explaining who they were, why they fell, and advising us on how not to follow in their footsteps. That possibility is beyond astounding. But it's deeply sobering too, because it implies a sort of great filter in operation on Earth. In astrobiology, the great filter is the idea that there's a step in the emergence of intelligent life that's extremely hard to get past, which might explain why we haven't heard from aliens. Here, we see multiple civilizations may have gotten to our level, but none, so far, got past the hurdles that followed, at least not in a way that allowed them to remain visibly present. They either self-destructed or otherwise exited the stage. The fact that Earth has had multiple advanced civilizations might indicate that getting to our level isn't exceedingly rare. But surviving long-term with advanced technology, that might be the tricky part. Maybe most civilizations on any planet eventually hit a crisis point, global war, environmental collapse, what have you, and fail. They leave behind a changed planet and perhaps some remnants, but no ongoing culture to speak of.
If that's true, it puts our current situation into stark perspective. We're bristling with nuclear weapons capable of ending our civilization in an afternoon. We're radically altering the climate and biosphere, potentially courting another mass extinction. We're developing AI and bioengineering that could either solve many problems or introduce new ones. This century, right now, might be our exam, the one that previous civilizations ultimately flunked. However, unlike them, we might have something akin to their study guide. By uncovering all this evidence, by learning about the Silurian hypothesis and finding these ancient markers, we're effectively being handed a cheat sheet written in the language of geology, chemistry, and myth. It's telling us, this happened before. Don't do what they did. There's even a possibility that this cheat sheet was intentionally left behind, that some part of the earlier civilizations wanted us to find it in time. Think of how we'd feel if we were on the brink of a disaster and suddenly archaeologists deciphered a library from 100,000 years ago where the authors described grappling with the same issues. It would be like looking in a mirror through time. We'd have specific examples of what they tried, what worked, what failed. Maybe they instituted global governance to prevent war, but it fell apart. Maybe they invented carbon capture or geoengineering, but it wasn't enough. Maybe they augmented themselves with technology, and it went awry. Knowing those things could literally save us from repeating them. And what if, beyond warnings, there are also blueprints for success hidden in their legacy? Perhaps some civilizations did find a stable path, at least for a while, and their ghostly hands are trying to guide us toward it. Some of the anomalies we see might not be warnings of doom, but hints at solutions. Evidence of clean energy technologies, for instance, or genetic adaptations that allowed sustainability. If we can read those hints, we might leap forward. So here we stand, at a pivotal moment. Humanity is unique in that we might be the first civilization on Earth to recognize that others came before us. That awareness could be our saving grace. It could unite us with a sense of purpose. Let's not waste this chance like the others did. And with a sense of humility. We're not gods. Others as powerful as us have fallen. It also reframes our potential future. If we manage to navigate this perilous transition and not only survive but thrive without collapse, we could very well become the first long-term spacefaring civilization from Earth. Essentially, the first to graduate from this planet's recurring cycle. We could eventually reach the stars and perhaps meet intelligences from other worlds who went through similar cycles on their planets. By then, we might have the wisdom of multiple civilizations, our own and all those that preceded us, to share in a galactic community. So, are we really the first civilization? All the evidence we've explored shouts a resounding no. But perhaps we can become something truly unprecedented. Perhaps we will be the first civilization on Earth to break the cycle of rise and fall, the first to endure and join whatever greater network of intelligences might exist out there. The clues of past ages surround us, urging us to learn and to do better. That 1.8 billion-year-old clue we began with, a fragment of ancient nuclear technology in an African mine, was just the opening chapter. In following it, we uncovered an epic story of worlds before us.
It has led us to a profound truth. We were never alone on this planet, and now the responsibility falls to us to carry this legacy forward. Our choices in the coming years and centuries will determine whether we transcend the fate of those who came before or simply become another layer of curious deposits in the rocks for some future intelligence to puzzle over. The saga of Earth's civilizations is still being written, and for the first time, we have the awareness needed to shape our chapter with the wisdom gleaned from all the chapters before. It's a humbling, awe-inspiring perspective. We inherit a world shaped by ancient hands, and we hold the pen that will write its next chapter. Let's make sure it's one worthy of the incredible history that made it possible.